All right, folks, let's talk about radio resource management. But first, let's say you weren't dealing with radio. All right, let's say you had a switch, and around that switch you had some clients. Okay, everyone's connected with their own little port. Maybe it's 100 megabit. Maybe we increase throughput, make it a gigabit or 10 gigabit. Life is good. What if we need to add 3,000 more clients? Well, then suddenly it gets a whole lot more complex, and we have lots of access layer switches working to distribution layer switches, working up to core switches, and we'll create links and redundant links between them all, and we'll have all these clients down here at the bottom. And you know what? It'll perform great because as far as layer 2 is concerned, our job is done. We've all got our physical connections with copper wire. We've got our logical connections. We've got full duplex communication. We're switched. We're fast. We're efficient. This is good stuff. But what happens when I have instead an access point with a couple clients connected to it? Okay, no problem. But wireless is no longer the periphery of how we do business. It's a core service. So let's say now we've got 3,000 devices all needing wireless access, which is by no means an out-of-bounds kind of thought. Well, those access points, remember, are going to be actually, of course, connected to our switches, and then we'll have wireless LAN controllers functioning to provide them with a point of access onto the network. And those will be connected to, again, switches that work their way up to the distribution layer. But what happens as we add all those clients? Well, suddenly, depending on how we configure it, that's a lot of noise because this is shared air. Right? We don't have the privilege of having an isolated environment. Instead, we're all in this together. We're all in one big pool. Your air is my air. It's CSMA CA, not full duplex switch networks. It's a half duplex environment. And even with beamforming and some of the great technologies that are now available to us, the fact is that our access points themselves are actually adding congestion to the network as we add them to provide coverage and support for more clients. So what are we going to do? Well, enter RRM, okay, Radio Resource Management, to dynamically balance the infrastructure and mitigate changes. Try and avoid the problem by designing it correctly in the first place. By keeping track of what we're covering, we can look at this because our access points are reporting to the wireless LAN controllers, and the wireless LAN controllers can communicate with each other and say, let's talk RRM. Oh, we're looking good. We're looking not so good. Not so good. Let's see if we can fix it, right? And again, it'll adjust radio spectrum components, right? We'll look at that specifically here in just a sec. Doesn't fix a site survey. It doesn't fix a poorly designed network. It doesn't create spectrum where there isn't any. You still have to work within your boundary box of the 2.4 and 5 gigahertz range, for example. It can't build new channels for you. And if you've designed a network appropriately, then it should be having to deal with the exceptions to the rule, not a constant problem. So you want to position things correctly in the first place. But what can it do for us? All right, first, understand it's a very dynamic aspect. When we enable RRM, then as we add new wireless LAN controllers with various access points underneath them to the network, they will join the fold and they will be able to be automatically added, and the information that those access points have gathered, including what other access points they're in communication with that they can hear, will be brought to us. And so it gives us a picture of the entire map of what's going on, which then we can use to control that behavior and make it efficient. All right, we continue to do that through technologies like DCA, TPC, and CHDM. Okay, you want to know these technologies, pretty straightforward. Dynamic channel assignment. All right, I'm using channel 1 for this SSID. You should use channel 6, shouldn't you? Yes, you should. How does it select that appropriately? Through this protocol, DCA. They're all going to observe and choose the best channel. And again, air quality is monitored. And if there's other things that are occupying that channel, then if 11 is available, then it would jump to 11. Of course, those are 2.4 gigahertz examples. 5 gigahertz would have some different numbers, like 36, for example. Transmit power control and CHDM, coverage hole detection and mitigation, those are not about the channel, right? They're not about the frequency. They're about the amplitude or the transmit signal strength. So transmit power control can adjust the power to bring it down if our access points are too close to one another, or build it up if we do not have sufficient coverage. All right, so it's based upon our initial topology. This is going to be what we use to get a consistent level of coverage for our clients that are traversing through our network, right? That might be roaming from one AP to the next. There's version 1 and version 2. You want to use version 1. Version 2 should only be used with Cisco technical support. So again, just stick with the transmit power control that is safe. You're talking about power. There's government regulations and things like that that you need to stay in compliance with. Version 1 does that. Coverage hole detection and mitigation. So let's say you had these 4 access points plus a 5th one. And this worked great to provide coverage for users that might be roaming throughout the network. But then let's say that last one goes offline. Suddenly there's a hole in the network. And wouldn't you know it, there's clients in that hole. So what are you going to do? Coverage hole detection would be set up so that if an access point goes offline, the wireless LAN controller running radio resource monitoring could inform these other access points that they need to increase their transmit signal in order to provide coverage. However, it might even be that one of them increases their signal to the point where it's reaching out into this middle area, but then the other one should decrease its signal so that we aren't actually overlapping each other too much. See, it's not just a free-for-all, it's got to be controlled. That's the beauty of RRM, is that it's going to dynamically manage this for us. Best practices for this involve, again, one key thing, which is you don't want it to be in flux when you are actually building your wireless network. So get everything placed first. Bring up your wireless LAN controllers, bring up your access points, then you turn on RRM, because nothing is going to appear and disappear and change the behavior of it and have it start waffling back and forth. You want to give it a stable environment to start off with, and it will respond much more the way you'd like.